Right, so now we're leaving Crosshaven and we're heading outside Cork Harbour to do some seabed mapping. Right, so now we're in the middle of Cork Harbour, just departed from Crosshaven, and we're about to start the survey, and Ron is going to tell us what we do first before actually embarking on the multi-beam survey.
Sure, so the thing to think about when we're doing a multi-beam survey is we're using sound to measure the distance from a sonar head down to the seabed. So in order to measure this distance accurately, we need to know what speed the sound travels through the water column. So what we're going to do first, and continuously throughout the day, is we're going to measure the speed of sound of the water column. We're going to use this castaway unit here that colleague August is about to throw over the side, and it's actually kind of revolutionised the way we survey, in that it takes a position, it accurately measures the speed of sound, and uploads itself automatically into the format that we need. So it's an excellent piece of kit. We take up to 20, 30 of these measurements every day, and that removes all refractions and problems with sound velocity differences, especially in coast to coast where you have kind of rivers, mixing of fresh water and seawater, and this kind of takes care of those problems. So August is about to deploy it now, so I'll just run a video. It also records other oceanographic measurements as well as helping with our kind of multi-beam data quality. It also is a separate data set in itself. So anybody interested in salinity, density, temperature in and around this area, really interested.
Right, so now
now you see it's going to use Bluetooth, and we're going to look at the profile straight away. Make sure it makes sense.
Alright, so the data is getting from this device to computer via
Bluetooth
wireless connection.
It makes our life a lot easier. So you can see this shows it's communicating, this little blue light, and in a minute now it should pop up on the screen. Finish the download, and there we go. You can see the variation in the sound velocity going from 0 meters down to just over 20, which is where we just dropped this. Also, maybe August, you want to show them some of the other variables and some of the other profiles. So we can also measure the comparison and compare the results we're getting between
different days,
and even different casts.
15 minutes apart. These shares from yesterday, 15 minutes apart, and maybe 2 kilometers distance. 15 minutes apart. See how it changes.
So we see that it probably changes due to influx of fresh water from River Lee, is it?
Yeah, most likely, yeah.
This is further up the river, and this is further down the river, taken 15 minutes apart. See the difference, how it changes. And this, we are seeing the changes up to 2 to 3 meters per second, which is a lot for us. Because, as Ronald mentioned earlier, this is the key element in the formula to measure the speed of sound. So the time when we send the signal, the time when we receive it back, we have to know the travel distance. And so to know the speed of sound in the water column gives us the final and the accurate and the correct depth.
So then the speed of sound is used to calibrate the multi-beam.
Well, what happens is basically you've got 512 beams. Each one of them will travel at a slightly different speed, especially as it hits lenses of fresh water in the water column. So you get this kind of curving effect, or frowning effect, smiling, curving, and basically this information, once we apply it to the data, gives us a smooth surface.